Good morning, chemistry. Today we're going to take a look at some more of those ionic formula naming and writing problems that we got yesterday, because based on some of the question answers that I got back, some of y'all still need quite a bit of practice with this, and I thought it would make more sense for us to get this down really well before we start working in the covalent. So we'll see how things go today. We might get to the covalent stuff tomorrow, or we might just have to wait until after Thanksgiving for that. I wanted to start by looking at the two problems that I assigned for you if you didn't make it to the Zoom yesterday, and that was problem number 10 and problem number 36. Some of y'all got awfully close on number 10, but you did leave out an important part, so let's start by talking about him. We've got the formula Cu2O. Cu, when you looked it up on the periodic table, you did figure out that yes, Cu is copper. But I think at this point a lot of people didn't bother to check to see if copper just had one oxidation or if it had more than one. And if you look on the chart here, copper shows up as +1. Copper also shows up as +2. So what we have to do is we have to figure out whether this is copper 1 or whether this is copper 2. So we're going to take a look and see what it's bonded to help us figure that out. And it's bonded to an oxygen. Over here in oxygen, we find it's just oxide. And according to our chart, that's a -2 ion. So I'll go ahead and write in oxide. Now I'm going to pull up some scratch paper on the side here, give us a little more room to work. So this is copper. We still don't know what its charge is. We know that oxide has a charge of -2. Now since there's only one oxygen atom in Cu2O, we know that all of that negative charge has to be coming from that one atom. So the total charge on the negative side is going to be -2. Which means that our total charge on the positive side has to add up to +2. Now, since I've got two copper atoms, how much charge does each one of those copper atoms contribute out of this 2 right here? Somebody unmute and tell me real quick. Just hit your space bar, tell me a thing, and then unhit your space bar. Or I could sit here for half an hour and you guys could watch me floss or something. That'd be fine too.
What was the question again?
Okay. The question was, I've got two copper atoms. I've got a total charge of +2, so how much charge will each of those copper atoms have?
One.
They'll have +1. That's absolutely right. Okay. Another way to look at that is if you imagine I've got an oxygen atom here, and it's got two negative charges. I've got two copper atoms hooked up to it. So if all of those charges are going to balance out and add up to 0, then I've got to have one positive charge per copper atom. See? So that tells me that this copper has got a charge of +1. So when I come over here to my name, I write that it's copper 1, Roman numeral 1. That tells me that the copper I'm dealing with is this copper right here. Okay, and it's very important that that's part of your name. This is a really good place for a question. If you've got one, feel free to shout it out in the chat or just speak up on the voice chat. While you're thinking about it, I'm going to go ahead and look at number 36, which is vanadium 5 nitride. Now, I know some people, and I get this every year, so if it's you, don't feel bad. I have some people that come to me and tell me that they really don't understand Roman numerals. And so my answer to you is just, well, take a look at the chart here, because all the ones that are in positive 1 look like that, all the ones in 2 look like that, all the ones in 5 look like that. So if you didn't know that V was 5, you could look on the chart here and it would tell you. Okay, and sure enough, there's a vanadium with a V. So here's how I'm going to figure this out. I'm going to get my scratch paper again. If I know that vanadium has a charge of plus 5, and I know that because of the V right there, now I'm going to look up nitride. And I had several people, they tried to look up nitride, but they looked at the wrong thing. Let's see, nitride would be in the ends. Okay, so here's what happened. Oh my gosh. Okay, so this is perfectly understandable. I see why people were getting this wrong, because I didn't put nitride on the dang chart. I'm going to have to go back and fix that. Okay, so that falls under my bad, not yours. Some of y'all got this right anyway, so let me just add nitride to the chart here. Nitride, oh, wait a minute. Nitride's on the chart. It doesn't go in -1. It's down here in -3. Okay, I knew that. So I didn't break it. It's all good. But anyway, several people, I think they read that and they thought that I was talking about nitrite or nitrate, because I got some NO2s and I got some NO3s as answers. Okay, but nitride is just nitrogen by itself. It's got a -3 charge. So coming back to my scratch paper right here, so nitride has a charge of -3. So a couple of ways that I can look at this. I can either do the crossing over trick, which means that I'm going to take this 5 and it's going to cross down here. And I'm going to take this 3 and it's going to cross down there. And that's one way that I can get my correct answer. But let me show you why that makes sense. Okay, I'm going to do kind of like what I did here. I'm going to represent these as little boxes with charges. So if I've got a vanadium with a +5 charge, then it's going to have 5 little pluses on it. Okay. Now nitride, according to my chart, only has 3 negatives. 1, 2, 3. So just one V and one N is not going to be enough to make sure that all my positives and all my negatives match up. So I add another N because I need some more negative charges. 1, 2, 3. Well, see, now my problem is that I've got too many negatives and not enough positives. So I'll add another +5 vanadium down here. Okay, I need another N to cover up some of those. Covers 1, 2, 3 of them. Still not all the way covered, so I'll add another N. Cover 1, 2, 3 of those. Well, see, now I've got too many negatives again, so I'll add another one of my +5 vanadiums here. Okay, so that matches up with those two. You see where this is going? So if I count how many total cards or how many total atoms I've got right here, I've got 3 vanadiums. That would be V3. And I've got 5 nitrogens or 5 nitrides. That would be N5. So either way, that's my answer. So come back over to my paper. It's V3 N5. This is a really good place for a question. If you got one, speak up or type it in the chat. Or, since this is all about working some more practice problems, we're only about 10 minutes in. At this point, I would be happy to take suggestions for numbers. And I'll be happy to work them with you or for you. So where do you want to go? What do y'all think? And you can just tell me in the chat there. What do you think is harder? Do you think it's harder to write the names if you're given the formulas? Or do you think it's harder to write the formulas if you're given the names?
The formulas.
Think it's harder to write the formulas? Okay, then let's spend some time on the formulas. And just looking at the second page right here, y'all give me a number and we'll go work it. I hear a vote for number 23. Sounds good to me. Let's go look at 23 real quick. Okay, 23 is titanium 4 selenide. So, scratch paper. So I know that titanium has a charge of +4. And I need to find selenide on my chart. Under the S's, there's selenide. Is that right? Oh, you know what? That definitely is a typo. So let's fix this real quick. Since I've got two SeO4s, selenide is just Se by itself. So let's get rid of that second O4. I update this thing every few years, and it's been a while since I have on this one, so it is possible I made some mistakes. That's the only other place where it could be. So selenide by itself is just selenium, so just Se, but according to this, it's got a charge of -2. So here's Se with a charge of -2. Okay. Looking at this both ways, let's look at it using the crossing over trick first, which means I'll cross the 4 down there and cross the 2 down there. So I'd have Ti2 Se4. Now, can I reduce that ratio of 2 to 4?
Yes.
Yes, I can. Absolutely. So I can reduce that down to 1 and 2. So in other words, according to the crossing over method, the answer is going to be Ti Se2. Let's do it by drawing pictures of our ions, though. So if I've got a Ti that's got 4 positives on it, and if all of my selenides, all of my seleniums just have -2, you see this way how I'm going to need one more selenide to cover up those positive charges? So again, I've got Ti1, Se2. Get the same answer either way there. After you fix your chart again. So I'll be sure and put a picture of that out in the chat that y'all need to, well, since I've still got all your paper copies that I'm going to give you next week here, I'll just go through and find myself some whiteout and fix that. Okay, let's do another one. What do y'all want to work? Okay, got a vote for 40, I got a vote for 28, vote for 25. Let me look at those. I'm going to say 40 because 40 I think is one that you guys can do. Uh, might work 29, might work 28. Actually, I've already worked 29. Worked that yesterday. And I've got the answer right there. Vote for 36. I just worked 36. So 28. Okay. 28, 27. All right. Let's look at, we'll do 27 and 28. That sounds good. Okay. So number 27, beryllium hydroxide. Now, you see how it doesn't give me a Roman numeral there? Okay. That tells me I've got to go find what the charge of beryllium is. Beryllium symbol is Be, and there it is right at the top of the positive 2. So write down that I've got Be with charge of plus 2. Hydroxide is one of those that I have to go look for on the negative side here. It's under the H's. There it is right there. Okay. Hydroxide is OH, and it's in the -1 column. So OH has got a charge of -1. So using the crossing over trick, I cross the 2 down there, I cross the 1 down there, which means I'm going to have Be1, OH2. I have to put the parentheses on the OH because they're a polyatomic ion. They're a group. I never did put up that Muppet video. I'll have to put that up in the stream later, talking about polyatomic ions. So beryllium hydroxide, Be, OH in parentheses, 2. And then number 28. Number 28 is zinc carbonate. Again, since it doesn't give me the charge, I have to go hunt around on my chart until I find zinc. Symbol is Zn. Hey, it's also a positive 2. Write that where you can see it, Zn plus 2. Oh, you know, every year people always kind of chide me because they have a hard time telling the difference between my 2's and my z's. Okay, so I'm going to do this for you one time just so there's no question. Okay, watch carefully. Here's a 2, here's a z. Any questions? I'm kidding. Okay, when I draw z's, I put a little crossbar on them, so that's actually Zn plus 2. Okay. All right. Wait a minute, you're saying Zn is positive 2 and positive 4? I don't believe it. Oh crap, I do have Zn and positive 4 up there. I wonder if that's another typo because I'm 99% sure that Zn is always just plus 2. Let me check real quick. My ancient periodic table thing here. Yeah, Zn is always just plus 2, so that's another typo. Thank you, Haley Jones, for pointing that out. So come up to your positive 4, and you can get rid of that. And I will do the same on the digital copy, and I will do the same on your paper copies. Thank you very much. Okay, Zn's plus 2. And let's see, we're doing number 28. So carbonate. Let's go find carbonate on the negative side listed under the C's. It's not there. Not there. Wait, where is it? Oh, there it is. It is on -2. It's CO3. So CO3's got a charge of -2. So coming back over to our paper here, CO3 has a charge of -2. Now, somebody look at this real quick and make an observation or make a conclusion for me based on what you see here. Only one of each ion. Yes, you're absolutely right. Because if this one here is +2 and this one here is -2, then just one of these will cover up just one of these. So I don't have to have two of those and two of those in my answer. I just come over here and I just write down Zn1, NO3 1. And again, if you want to put NO3 in parentheses, wait, it's not NO3. Why you guys let me do that? CO3. If you want to put CO3 in parentheses, even if there's only one, that's fine. Okay? But typically, if there's only one of those, you don't have to, because remember, we always know the first thing that we come to is going to be the positive piece, the cation. Everything else has to be the negative piece. Okay, so let's look. Okay, so let me look in the chat. I've already worked 36. Already done 29. Okay, we could look at 25 real quick. Okay, 25 is gallium chloride. Please don't tell me that I accidentally put gallium in more than one place too, did I? Let's check the chart here. So gallium's symbol is Ga. And there it is, down in +3. Let me scoot things around here. Okay, so gallium chloride, Ga is +3. Chloride is over here in the -1. It's just Cl, just chlorine. So using my crossing over trick, 3 goes down here, 1 goes down here. So it's just going to be Ga1 Cl3. So backing back out there, I've got several examples worked on this side. We're at 23 minutes. Let's go work a few examples over on the front side, and then I think I'm going to let y'all get on with your day here. Does anybody have any questions on the back side before we move on? All right, so how do you know if you're supposed to put it in parentheses? That's a good question. So if you take a look at some of the examples I've got right here, that one's in parentheses because I had to have more than one of that ion. So anytime you're going to have to add a number outside of it, a subscript outside of it, then you have to put it in parentheses. Like same thing right here with my ammonium oxide, I had to have 2 ammoniums. So I had to put the NH4 in parentheses and put a 2 on the outside. SO4 had to go in parentheses with 2 on the outside because I had more than one of those. I didn't have to do it here because I only have one group of CO3. Okay, you can, and it's perfectly okay if you do, but you don't have to. If you look at some of the examples on the front side, some of them are in parentheses and some other ones are not. And the ones that are not, it's because there's only one of them. Like, look at number 7. Have we done number 7 yet? Let's do number 7 and I'll explain what I mean here. So I've got Li2SO3. Keeping in mind that it's always positive piece before negative piece. My positive piece is going to be lithium. My negative piece is going to be everything that's left over. Since it's not in parentheses, I know that that is just a single ion. So first of all, I'm going to check to see what lithium's charge is on my chart. Lithium's +1. If there's not a Roman numeral here, I don't have to put a Roman numeral in my name. So it's just going to be lithium. Now let's go find CO3, or I'm sorry, SO3. There's SO3 right there. It's sulfite, F-I-T-E, not sulfate, sulfite. So this is a classic case on number 7, lithium sulfite. Questions? Suggestions? Somebody pick out another one and let's go do it. Here, vote for number 3. Did I do number 3 on the video? Maybe I didn't do number 3. Vote for number 19. Okay. All right, fine. We'll do number 3, then we'll go do number 19. Okay. Oh, good choice on number 3. Got to vote for 15. Okay. We can. No, I told you yesterday I don't want to do 15 because that one's way too much. Okay, fine. We'll do 15. Just hold up for a minute. Okay, let's look at 3 first. V2SO43. Now, V is vanadium. Okay, we've seen that before. And we also know from experience that vanadium is one of those that has different possible charges. So let's go find what it's bonded to and see what kind of total charge that carries. So it's bonded to SO4. On my chart, SO4 is sulfate, has a charge of -2. Okay, so it's going to be vanadium something sulfate. Now over off to the side. Okay, so sulfate is SO4. It's got a charge of -2. But in this molecule, it's V2SO4 3. So what's my total negative charge on this side of the molecule? Am I talking too fast or too slow, or why is nobody answering? -6, very good. Okay, we get that by saying that there's 3 of them and each one is -2, so 2 times, or -2 times 3, my total negative charge is -6, which means my total positive charge has to be +6. That +6 is being divided out over 2 vanadium atoms. So what charge does each vanadium atom get?
3.
Yes. So just to double check, let's see if I have a vanadium over here in my +3 column. And sure enough, I do. So this is going to be vanadium 3 sulfate. Okay, number 19. Okay, CuNO22, cool. Now Cu is copper, right? We already know that copper, again, just from prior experience, we know that it could either be +1 or +2. That's also the only 2 places it shows up on the chart there. Let's go find NO2. NO2, I think it's going to be nitro something. There it is. NO2 is nitrite, ITE, and it's in my -1 column. So for my name down here now, it's going to be copper something nitrite. But let's take a little bit closer look at that. So if nitrite is NO2, it's got a -1 charge. I've got 2 of them in CuNO2. Since I've got 2 of these and they're -1 each, that means I've got a total charge of -2, which means I have to have a total positive charge of +2. And since there's only 1 copper atom to carry that, I know that that copper has to be copper +2, or copper 2. So my answer is copper 2 nitrite. All right, let's look at number 15, because I can see where you could get confused on this. This is one of my favorite compounds of all time, by the way, because it's really just this gorgeous purple crystal. It makes this really cool dark purple solution. When you dissolve it in water, it looks like grape juice that would kill you. But let's take a look at this. So I've got K for my positive piece. Everything else right here has to be my negative piece. Okay? Now I can see how this could confuse you, because if you get on the negative side, there's two places where MnO4 shows up, if I'm not mistaken, right? Let me see. It shows up right there in the -1, where they call it permanganate. I think it shows up somewhere else and they just call it manganate. Yeah, as MnO4 up here, and it's -2. So what we've got to decide is this MoO4 that's -2, or is this MoO4 that's -1? So this is actually a case where we have to look to see what it's bonded to. It's bonded to potassium. Potassium is always +1. So if this potassium has a +1 charge, let me find one more place to put that. So if my K is +1, I've got an MnO4 over here. What does its charge have to be in order for this to make sense?
-1.
-1, excellent. Okay, so when I go to find MnO4 in my -1 chart here, that's the one that starts with a P, so it's permanganate. So what I've got here is a classic case of potassium permanganate. Now notice that I don't have to put a Roman numeral in there because potassium doesn't have a Roman numeral beside it in the chart. That's the only flavor potassium comes in is +1. So I don't have to put potassium 1 permanganate. Let's see, we've been going 33 minutes. I think we have time to do maybe one more, and then I will leave y'all alone for the day. What do you want to see? Got to vote for 16. Got to vote for 18. CDSO3 or PB3N2. Got another vote for 18. Okay, so both of those are good. Both of those, I'll tell you this right now, that one you will need a Roman numeral with because there's more than one kind of lead. I think we'll also need a Roman numeral for 18 because there's more than one kind of cadmium. Oh, got to vote for 4. I'm going to leave you to do 4 by yourself because, like I said, that one's fun. And yeah, I'm going to let you figure out 4. It's easier than you think it is. Let's look at number 18. CDSO3. Okay. When I look up CD on the periodic table, I know that CD is cadmium. But the problem with cadmium is cadmium shows up in more than one place on my chart here. No, wait, does it? Oh, you guys suckered me into doing an easy one. Cadmium only shows up in +2. Okay? So let's go see if we can find what SO3 is. Look on the negative side for SO3. There it is. Negative. It's a sulfite. It's got a charge of -2. So since cadmium is +2 and sulfite is -2, that makes sense. I don't have to put Roman numerals because cadmium only comes in one flavor. So it's just going to be cadmium sulfite. Oh, you guys talked me into doing an easy one. 16 is a lot tougher. Okay, fine, we'll do 16. We have PB3N2. PB is lead. And I know for a fact, I'm not just making this up, that lead comes in different flavors. So it's bonded to N. N, if you look it up on your periodic table, is nitride with an IDE. And just from looking at it a minute ago, we also know that, where'd it go? That nitride has a charge of -3. Okay? So I'm trying to find my charge of PB. Looking at my original formula, it's PB3N2. So what's my total negative charge on this side of the molecule?
-6.
Excellent. Which means my total positive charge has to be
6.
+6. Good. I am dividing that out over 3 lead atoms. So Pb, Pb, Pb. So if I have to send equal charge to each of these guys, how much will each one get?
2.
2. So this is a classic case of lead +2. And to double check that, I look at my +2 column, and sure enough, lead can be +2. So this is going to be lead 2 nitride. So with that, between what we've worked here and what we worked on the back and what I worked in the video the other day, there's not just an awful lot more of these that are left over here. So here's what I'd like you to do. I am not assigning this as homework. We are going to look at this some more after Thanksgiving because everybody's going to need to kind of dust off those brain cells. But after you've got your work done for your other classes today, come back and take a look at some of the ones that you've left blank. Now you might be sure and work those in pencil or put a star out beside them so you know that they're ones that we didn't work together. And then we'll take a look at them when you get back from Thanksgiving break. I think we're going to go ahead and end this now, and tomorrow we're going to take a look into covalent, because covalent is a lot easier to figure out. I think you guys are going to get it like that. So